Alright, so, hey class. We have our audience here. My dogs. Max wants to eat the prop, but he can't, so. Daisy? Daisy! She's so attentive. Daisy! Alright, let's get to it. So, here's my mom. She's getting me 10 extra credit points, so she's on video. Okay, so, the first law of motion is an object at rest remains at rest, and an object in motion stays at motion at a constant velocity unless it is acted upon by a net external force, which is all the forces added up together. Okay, so this gumball demonstrates the force, not the force, demonstrates a object, and it is remaining at rest right now because no external force has acted upon it yet. But after my mother hits it to go forward, then a force has acted upon it.
Leave it.
Dogs. They just want the gumball.
Leave it.
And once my mother hits it, it will be acted upon by a net external force. So, Mother, will you do that? There you go. And that is the first law of motion. Thank you. Alright, hey guys, I'm back. So, on the left, we have a golf ball, which has notably more mass than this ping pong ball, which is very light. So, very light. And, okay. And this one has more mass, because it is heavier and it is a golf ball. So, okay, so to demonstrate the second law of Newton's second law, which is the acceleration of an object is directly proportional to the net external force of the object and inversely proportional to its mass. Now, in order to do this, we are going to blow dry both golf balls. Not golf balls. One's a golf ball and the other is a ping pong ball. And we will see which one goes farther. So the one with more mass will go less far because it has more mass, and the ping pong ball will go further because it has less mass. So let's try it out. So as you can see, the golf ball went less far than the ping pong ball, which traveled a long way away and then went around for some reason. But air resistance discluded this experiment worked because, and proved that the second law works because the mass was less on the ping pong ball, and it went further distance, and the mass of both of objects affected how far it would go because of the second. Alright, so we are back for the third time now, and Daisy wants the ball again. Oh, here comes the other one. He's dancing. Okay, guys, get out of the video. Come on. Alright, take two, guys. So the dogs are now in their cage called Betty Bunks. Okay, so the third law is going to be represented by a super ball, and the third law is for every acting force there is a reacting force of equal magnitude in the opposite direction, and it is a action-reaction pair. So for this, we are having a super ball drop and come back up, and that will be, I will explain it when it happens. So here we go. Now, I'm going to have her do that one more time after I explain. So, first of all, the ball drops and the floor pushes the ball pushes down to the floor, and that is the action, the acting force. So when the ball goes down to the floor, it's the acting force, and when the ball goes up, the floor pushes it up as the reacting force. That's what makes the ball come back up in the air. So can you do that one more time, Mother? And that is how the ball and the floor work together as the action-reaction pair, representing Newton's third law. Thank you very much for watching, and I hope you had a good understanding and now have a good understanding of the three laws of Newton's laws of motion. Thank you very much for watching.